Few things are more captivating than the great beyond, the final frontier, the universe. Of the countless myriads of spiraling galaxies, radiant nebulae, clusters of stars, the universe can truly be called infinite beauty. But how do we observe its extraordinary phenomenon in such detail? What allows us such precision so far away? These questions give rise to the importance and influence of the Hubble Space Telescope. In recent astronomy, nothing has been more influential and divulging than Hubble. Its unique position is unobstructed by atmospheric distortion, providing us with nothing less than an absolutely stellar perspective of our universe. It has revolutionized space exploration, creating answers to questions and questions to answers, hence paving the way to more unprecedented discoveries.
It's there and it's pervasive throughout every area of astronomy, whether it's nearby with solar system things or the most distant galaxies in cosmology. Any field of area of astronomy you want to look at, it really, if not dominates like it used to, is there in the forefront.
But where did Hubble come from? How was this magnificent instrument visualized? The answers trace back as far as 90 years ago, when the German scientist Hermann Oberth first proposed the idea of an extraterrestrial observatory in his publication of The Rocket into Interplanetary Space. Oberth explained that a rocket could achieve the necessary velocity to break past Earth's gravitational pull and possibly the atmosphere. This position would allow an image unimpeded by atmospheric turbulence, resulting in a resolution 50 times clearer than that of ground-based observatory.
I guess Oberth was the big visionary. He had the dreams and the ideas and to some degree brought it to fruition. But when we go to the Hubble Space Telescope, the key character who pushed for something like that was Lyman Spitzer, a Princeton astronomer. And he realized early on, here Oberth planted the seed and had some basic ideas, but Spitzer was a driving force as far as getting funding, Congress and the Senate and the budget of NASA and the U.S. to be able to do that. So it was those people together, the visionaries and the first few steps and the first pathfinders, and then the people that really saw the light and wanted to get something like this done.
Spitzer was inspired by Oberth's ideas, and in 1965 headed the National Academy of Sciences to convince the scientific community and Congress of the Space Telescope's feasibility and advantage. Spitzer mentioned the quality of the angular resolution in space, as well as the ability to perceive unabsorbed infrared and ultraviolet light. Spitzer's persistence eventually paid off, and in 1966, the first orbiting astronomical observatory was launched. The first OA was followed by 3 others, 2 of which being absolute successes. Because of this, Spitzer was able to push a more ambitious, large-scale space telescope project, and thus, in 1975, the future Hubble began development.
They decided that a high priority was to get one that would work at visible wavelengths to reduce the turbulence. And they really wanted a flexible, multi-instrument telescope with lots of capabilities, and so they did it as a really big project.
After many generations of conception, realization, toil, and finally success, Hubble ascended to its proper place among the stars. However, success was short-lived. The first images Hubble sent back were not what NASA had anticipated. Hubble's mirror was flawed.
They tested the primary mirror on its own, and they polished it to a very accurate shape, and they had made a lens to mimic the rest of the optics, and they had made a mistake in making their test lens. That said, it could, even in its flawed state, it could do science that could not at the time be done from Earth.
NASA resolved to fix Hubble by attaching an instrument known as COSTAR.
It basically put a corrective set of optics in. It's like we gave it eyeglasses.
Thus, 7 astronauts embarked on Hubble's first servicing mission to install COSTAR and translate light onto the main mirror.
Thanks to the servicing missions, it was possible to put on the glasses and get well over 90+% of what originally been hoped for by making that modification.
Hubble was fixed, setting forth a new era of space exploration.
When I took astronomy as an undergraduate in the 1960s, the mid-60s, the textbooks had mostly black and white pictures, mostly with Earth-based telescopes. The moon program had been done, and there was some nice stuff there, and a little bit of planetary exploration. But by the time Hubble came around in the 90s, the pictures were so beyond what could be done. For a while, it was the ultimate observing tool for the astronomer.
There were other space telescopes before at like X-ray wavelengths, but they didn't send back beautiful pictures that got the public excited about astronomy, and everyone knows Hubble.
Galactic astronomy or stellar astronomy or solar system astronomy, it's got something for everybody there that's just amazing.
For us, it's much more of the techniques and the nitty-gritty of astronomy. For most people who look at stuff coming out of Hubble, it's the pretty pictures, and they're wowed by them.
I think that all the images it sends back give us a great context for where we are in the universe, what's around us. There's far more than you see in your daily life.
Yeah, I think what it's done is we've brought the universe into people's homes through their computers. That's how it's really changed things for most people.
Day by day, new discoveries are made. Night by night, we have a clearer view of a starry sky. We have learned that our universe extends beyond the sliver we are exposed to, beyond the Milky Way and into the vast reaches of infinity. These insignificant specks are not stars, they are galaxies, tens of thousands of them.
They picked the darkest spot of the sky they could find, and they looked for a long time to get pictures of the faintest things out there, looking for galaxies very, very far away. And the deep field and the ultra-deep field are the result of those observations.
One galaxy alone may hold several billion solar systems and hundreds of billions of stars. Now multiply that by 10,000 and we get this, a mere scrap of the universe. Hubble has made us realize that the cosmos is far larger than anyone had dreamed of imagining, and that we have much to learn.
I think it raises questions about the early universe.
Humans are curious animals.
How did galaxies get from how they look there to how they look now?
What am I? Who am I? Where am I? Why am I here? What is this all about?
To understand where we came from, how it all happened. That's really it.
And by knowing more about the whole universe, it makes us realize what we are, where we are.
Where did it all come from and why did it all come from? That's really the goal.
Black holes are no longer science fiction. The age of the universe has been pinpointed. The Coma Cluster, hypernovae. Hubble is the pinnacle achievement in space exploration, the bridge to the boundaries of the universe. But despite its reputation, it can't last forever. Hubble's orbit is decaying as we speak. Scientists have installed a soft capture mechanism to peacefully guide Hubble's descent into the ocean, but this leaves a gap in our bridge. What will fulfill it? The answer is the James Webb Space Telescope, Hubble's successor. And now we continue the search for our origins, bearing our universe, discerning our cosmic ocean above the atmosphere. Through Hubble's discoveries and its successors, who knows what we can find? It will be remembered as the first large space telescope, but more importantly, the initiator of truly unprecedented things.